It's Biomed Cafe menu. Oxidative phosphorylation will be presented today. We will talk about oxidative phosphorylation discovery, electron transport chain, chemiosmosis, and quiz game. I'm Dr. Biomed, cellular and molecular biologist. Hi everybody, welcome to the Biomed Cafe channel. In this channel, complex biological and medical contents are presented in a simple, classified, and summarized form. Oxidative phosphorylation discovery. They saw something others didn't see. Benjamin F. Kingsbury in 1912 first related mitochondrion with cell respiration. In 1939, experiments demonstrated that cellular respiration using 1O2 can form ATP. In 1946, Albert Claude concluded that cytochrome oxidase and other enzymes responsible for the respiratory chain. Biologists in 1948 discovered that mitochondria are the site of oxidative phosphorylation in eukaryotes. Cellular respiration steps. Cellular respiration has 4 steps. Step 1. Glycolysis. Step 2. Pyruvate oxidation. Step 3. Citric acid cycle. And Step 4. Oxidative phosphorylation. Oxidative phosphorylation. Oxidative phosphorylation steps. Oxidative phosphorylation has 2 parts, electron transport chain and chemiosmosis. Electron transport chain has 3 steps. Step 1. Delivery of electrons by NADH and FADH2. Reduce electron carriers NADH and FADH2 from other steps of cellular respiration transfer their electrons to molecules of the transport chain. In the process, they turn back into NAD+ and FAD. Step 2. Electron transfer and proton pumping. As electrons are passed down the chain, they move from a higher to a lower energy level, releasing energy. Some of the energy is used to pump proton ions, moving them out of the matrix and into the intermembrane space. This pumping establishes an electrochemical gradient. Step 3. Splitting of oxygen to form water. At the end of the electron transport chain, electrons are transferred to molecular oxygen, which splits in half and takes up proton to form water. Chemiosmosis. Chemiosmosis has 1 step. Gradient-driven synthesis of ATP. As proton ions float down the gradient and back into the matrix, they pass through an enzyme called ATP synthase, which harnesses the flow of protons to synthesize ATP. Electron transport chain. Electron transport chain, or ETC. The electron transport chain is a series of proteins and organic molecules found in the inner membrane of the mitochondria. Electrons are passed from one member of the transport chain to another in a series of redox reactions. Electron transport chain occurs in eukaryotes, in the inner mitochondrial membrane, and in prokaryotes in the plasma membrane. Electron carriers. Electron transport chain has 2 carriers. NADH, and FADH2. NADH. It can transfer its electrons directly to complex 1, turning back into NAD+. Its electrons are at a high energy level. Complex 1 pumps protons from the matrix into the intermembrane space. FADH2. It can transfer its electrons to complex 2, turning back into FAD. Its electrons are at a lower energy level. Complex 2 does not pump protons across the membrane. ETC proteins. ETC proteins are following as complex 1 or NADH ubiquinone oxidoreductase, complex 2 or succinate dehydrogenase, coenzyme Q, complex 3 or cytochrome BC1 complex, cytochrome C, and complex 4 or cytochrome C oxidase, complex 1. NADH turns back into NAD+, transferred its 2 electrons to FMN within complex 1. FMN passes the electrons to an iron sulfur or FES protein. FES transferred the electrons to a small carrier called ubiquinone. 4 protons pass from mitochondrial matrix to the intermembrane space, contributing to the electrochemical gradient. Complex 2. FADH2 turns back into FAD and transfers into electrons to FES protein within complex 2. FES proteins passes the electrons to ubiquinone. No protons are translocated across the membrane by complex 2. Complex 3. Ubiquinone transfers the electrons to cytochrome B1. Cytochrome B1 passes the electrons to FES protein. Then FES protein transfers the electrons to cytochrome C1. After that, cytochrome C1 passes the electrons to cytochrome C. 4 protons pass from mitochondrial matrix to the intermembrane space, contributing to the electrochemical gradient. Complex 4. Cytochrome C delivers the electrons to cytochrome A. Cytochrome A transfers the electrons to cytochrome A3. After that, cytochrome A3 passes the electrons to O2. O2 splits into 2 oxygen atoms and accepts protons from the matrix to form water. 2 protons pass from mitochondrial matrix to the intermembrane space, contributing to the electrochemical gradient. Chemiosmosis. Chemiosmosis. In this process, ATP synthase uses energy of proton gradient to make ATP. It's not unique to cellular respiration. It is also involved in the light reactions of photosynthesis. ATP synthase is a lot like a turbine in a hydroelectric power plant. Instead of being turned by water, it's turned by a flow of proton ions moving down their electrochemical gradient. as ATP synthase turns, capturing energy from the proton gradient as ATP. In chemiosmosis, ATP synthase uses the ETC-generated proton gradient across the inner mitochondrial membrane to form ATP. For every 4 proton ions, 1 ATP is produced. You can see here all steps of oxidative phosphorylation. ATP yield in cellular respiration. How many ATP do we get per glucose in cellular respiration? Glycolysis makes 2 ATP and 2 NADH. 2 NADH go to oxidative phosphorylation. Each NADH yields about 2.5 ATP, so 2 NADH produce 3 to 5 ATP. Pyruvate oxidation makes 2 NADH. 2 NADH go to oxidative phosphorylation. Each NADH yields about 2.5 ATP, so 2 NADH produce 5 ATP. Citric acid cycle makes 2 ATP and 6 NADH. 6 NADH go to oxidative phosphorylation. Each NADH yields about 2.5 ATP. So 6 NADH produce 15 ATP. Citric acid cycle makes 2 FADH2. 2 FADH2 go to oxidative phosphorylation. Each FADH2 yields about 1.5 ATP, so 2 FADH2 produce 3 ATP. Therefore, totally around 30 to 32 ATP are made in cellular respiration. Key points of oxidative phosphorylation. The NADH and FADH2 made in other steps deposit their electrons in the electron transport chain, turning back into their empty forms NAD+ and FAD. As electrons move down the chain, energy is released and used to pump protons out of the matrix, forming a gradient. Protons flow back into the matrix through an enzyme called ATP synthase, making ATP. At the end of the electron transport chain, oxygen accepts electrons and takes up protons to form water. Thank you for watching. Please subscribe to this channel, and if you like the contents of this video, please like it. Now it's time to the quiz game. I've put the link to the quiz game in the description of this video. Download it for free and enjoy it. Until the next video, bye!